Problem 8 gives us some information about weekly returns on 5 stocks. We want to perform some computations. Particularly, we want to know what the standard deviation of returns on an equal weighted portfolio is. So here is question 8 through 10 data. It is incredibly difficult to read. So what I'm going to do is delete these columns. And I'm going to delete this column. We don't need this for right now, but we may eventually. The other thing that I'm going to do is I'm going to hide rows, and I'm going to do this for a reason, which is that it makes it really a whole lot easier to do the calculation. So Zoom, notice that Zoom starts up only in April of 2019. We have to be careful about the way that we calculate values for Zoom. And so I'm going to hide rows. You'll see in a second. So I'm going to hide all the rows between the first row and the row ahead of Zoom becoming public. And then I'm going to hide all the rows after Zoom becomes public until the end of the data. It is less important on this question. It's more important on later questions. This question asks for the standard deviation of portfolio returns. So to do that, we need a variance covariance matrix. And the easiest way, in my opinion, to do these is to copy and paste all of the companies on the sides. And then here you just do equals variance. Oh, it's just var. Let's add a few more decimal places. In fact, let's just do that on all of them. Netflix equals var. Zoom equals var. Oops. And notice here, it's going to capture all the cells from April 26, 2019 when it's public to March 27, 2020, which is the last date that we have information. And we only have to do that on Zoom. Actually, it won't make a difference here, but okay. CoVar is the covariance equation. So this is GM and Netflix. This is a symmetric matrix. So here we're putting the covariance of GM and Netflix. Here we want to put Netflix and GM. It's the same number. And we're just going to do that all the way across. So covariance between Zoom and GM. Oops, and we can't use the whole GM. We have to use that part. Equals covariance between GM and CVS. Equals covariance between GM and Walmart. Okay, let's fill this in. This is Zoom, CVS, Walmart. Okay. Covariance between Netflix and Zoom. Covariance between Netflix and CVS. Covariance between Netflix and Walmart. This is Zoom and Netflix. This is CVS and Netflix. This is Walmart and Netflix. Covariance between Zoom and CVS. The covariance between Zoom and Walmart. Let's lock those. And finally, the covariance between CVS and Walmart. And let's reference that correctly. Next up is the weight matrix. The weight on all of these is 0.2, 0.2, 0.2, 0.2. I'll do it here just for, nope. You weirdo. There we go. You would do the weight on both of those sides times, so for each one you would reference the top and bottom. The weight is all the same on all of them, so I'm just going to copy and paste everything. Okay, now the portfolio variance matrix is just going to be this times this. That doesn't, yep, that's right. Okay, so let me put this in number form so that you can just see it. These are really small numbers. So what it says is the, oh, let me make sure that's right. Yeah. Each of these variances and covariances have a weight of 4%. And each of these, so when you multiply the variance of GM times the weight in the portfolio of GM, you get a really, really small number. So the portfolio variance is just going to be a sum of all of these. And the standard deviation is going to be this to the power of 0.5, which is 3.7%. So this is the standard deviation. If you wanted to check your work, one thing that you could do is do sum product of the variance covariance matrix and the weight matrix. If you do not get the same answer, you've done something wrong. The last step here is to get the annualized standard deviation, and that's this times 52 to the power of 0.5. Now, this is not a formula that I'm familiar with. I have not worked in the industry, and so this is not a formula that I've used. I will probably let you know if there's something like this on the test that we didn't go over in class. For this, just memorize it's 52 to the 1/2, or to the 0.5. So the answer is 22%, and you see in the solutions that that is the answer.